Okay, the last question. This is an example of what we call multinomial data. Instead of binomial where there are successes and failures, you could have multinomial ABCD kind of observations. And we actually have seen these before, we just never formally talked about what the distribution might be. So we assume that there are events ABCD and they correspond to the grade in the class, and the probability of A is supposed to be 0.5, probability of B is theta, probability of C is 2 theta, and the probability of D is 0.5 minus 3 theta because everything adds up to 1 and nobody fails. So in this particular case, theta must be between 0 and a sixth because all of these numbers have to be non-negative. And we want to figure out, though, what theta is from some data. So the class had 14 A's, 6 B's, 9 C's, and 10 D's, and we wanted to figure out the parameter theta here. How do we do it? First thing we do, if we want to find the maximum likelihood estimate for theta, is to write out the likelihood function, which is the probability of seeing 14 A's, 6 B's, 9 C's, and 10 D's. But in general, we could say A's, B's, C's, and D's, given you knew what theta is. Well, that likelihood function is going to be in the form of some constant times the probability of A to the number of A power times the probability of B to the Bth power times the probability of C to the Cth power times the probability of D to the Dth power, where A, B, C, and D are the number of respectively A, B, C, and D's. Now this coefficient is actually like the Mississippi problem. It tells you how many ways of all the grades, this is the total number of grades, you will have A's, B's, C's, and D's. So it's very much like the Mississippi problem. And you could calculate this coefficient using the counting methods we talked about at the beginning of the semester. Try it. But as far as I'm concerned, it's just a constant, so I can ignore it. If this is the likelihood function for theta, and I want to find the theta that maximizes it, what I would prefer doing is looking at the log of the likelihood function. The log of this, I'm just going to say, is the log of some constant, which is just really a constant, so I can ignore it. The log of this is going to be A times the log of 1/2, but again, as far as theta is concerned, it's a constant, so I could pull it in too. The log of this is going to be B times the log of theta, plus the log of this factor is C times the log of 2 theta, and then plus D times the log of 0.5 minus 3 theta. So all I did was take the log of the likelihood function. If I want to find the maximum likelihood estimate, I'm going to take the derivative of the log of the likelihood function with respect to theta. Now, the derivative of a constant is 0. The derivative of A log 1/2 is 0. The derivative of B times the log of theta, though, is B over theta. The derivative of C times the log of 2 theta is going to be C times, let's see, it's going to be something over the log of 2 theta, but times the derivative of 2 theta if I use the chain rule, so it's going to be times 2, which actually means it's just C over theta. And the derivative of the log of 0.5 minus 3 theta is, let's see, the denominator is going to be 0.5 minus 3 theta, and the numerator is going to be the derivative of this, which is minus 3 theta. Okay, so if I want to make sure that it's a max, I'd have to take the second derivative. I'm going to skip that because I'm tired. And so give me a sad face, because I should have made sure it was a maximum. But I'm going to solve this by setting it equal to 0. And the way I'm going to do this is multiply through by the lowest common denominator to get rid of the fractions. So I will multiply through by theta times 1/2 minus 3 theta. So I'll get 1/2 minus 3 theta times b plus 1/2 minus 3 theta times c plus minus 3 theta times theta, which is minus 3 theta squared, is equal to 0. So, solving, what do I get? Okay, I'm sorry, I'm wrong here. This derivative is not minus 3 theta, it's just minus 3. So it's just minus 3 to theta to the first, because the derivative of 1/2 minus 3 theta is just minus 3. I don't know what I was thinking of there, but it would have made problems. So now solving for theta, I ended up with 1/2 b minus 3b theta plus 1/2 c minus 3c theta minus 3, if there's a d here missing, minus 3d is equal to 0. Okay? And so, again, solving for theta, you end up with collecting all the terms that have thetas involved in them. You have minus 3b minus 3c minus 3d times theta. And the terms that don't have thetas involved in them, we have plus 1/2 b plus 1/2 c is equal to 0. I could write this as 1/2 times b plus c is equal to 3 times b plus c plus d times theta. Okay, which means solving for theta, I get theta is equal to 1/2 times b plus c divided by 3 times b plus c plus d, which is the same thing as b plus c divided by 6 times b plus c plus d if I combine the 1/2 with the 1/3 I get from here. And that's the maximum likelihood estimate. Ta-da! Again, what do? We find the likelihood function, take the log of it, take the derivative, set it equal to 0, and solve. Ta-da! The end.